We are going to check now to see if these two sets of three-phase coils can lift up this magnetic flywheel, which weighs about 300 grams when it spins, and if so, is there any change of weight on the scale when they do so? "16 hertz, 17 hertz. Beautiful, isn't it? Now it's really lifted up completely and wobbling. Look at that. Now the weight on the scale remains close to zero. 18 hertz. When it gets to the top of the field, it may fall out. "18 hertz. First, we're going to try with one set of three-phase coils elevated quite vertically from the other set, so the fields are a long way from one another. Turn on the power. Wobbles, about 5 hertz, 10 hertz, 15 hertz, 20 hertz, going up into the air, 22 hertz, 25 hertz, 30 hertz. No change in weight on the scale. Now we're going to study those two sets of three-phase wire coils very close to one another with a 300 millimeter spinning magnetic flywheel in the middle. 15 hertz. It's rising up at 17 hertz. When the coils are very close, it rises up quickly due to the strong field, but the scale hasn't changed. 18 hertz, lifting way up. No change of weight on the scale. Pretty cool, isn't it? 300 grams being lifted up by these two sets of coils, almost in phase with one another. Then it falls when it gets out of the field. Now the two sets of three-phase wire coils are very close, although staggered in position relative to one another. And there's a magnetic flywheel in the center. 4 magnets, all the same polarity, 300 grams. We're going to turn on the three-phase power to make it spin 7 hertz, and we'll see what happens to the effect on the scale. 10 hertz. It's not lifting up yet. 16 hertz. 17 hertz. Beautiful, isn't it? Now it's really lifted up completely and wobbling. Look at that. Now the weight on the scale remains close to 0. 18 hertz. When it gets to the top of the field, it may fall out. There it went. Hertz.